Hey y'all, welcome back. On tonight's homework, we've got a kind of a mixed bag here, but we did introduce some new transcendental and specifically trigonometric derivatives. So those will get kind of thrown into some of these quotient and product rule problems. So let's look at number one. It says if f of x equals 4x plus 3 over 3x plus 4, then find the derivative. We're going to have to use quotient rule here. So the derivative of f is going to equal the derivative of the top function. So that's going to be 4. So if this is my top and this is my bottom, then t prime, or the derivative of t, is going to be 4, and the derivative of the bottom is going to be 3. So luckily these aren't too complicated, and our derivative should be pretty simple to put together here. So anyway, we've got the derivative of the top, so that's just going to be 4 times the bottom function, so 3x plus 4, minus the top function, 4x plus 3, times the derivative of the bottom, which is 3, all over the bottom squared, 3x plus 4 squared. Now this is a multiple choice item, and we can see that most of these denominators do look like 3x plus 4 squared, so let's not bother multiplying that out. But it does appear as though the numerator has been simplified. So if this were a free response question, I would just say go ahead and leave it. But because we have to pick the correct answer choice, we're going to have to simplify that numerator. So I'm going to use the distributive property. Use the distributive property to simplify that. And then I'll combine my like terms on a separate step. 4 times 3x is 12x. 4 times 4 is 16. So really, we've got minus and a 3 here. I think what I'm going to do is just distribute a negative 3. So it's almost like I'm writing it like minus 3 times 4x plus 3. And so that way I can take care of that negative and not have to have an extra set of brackets here. So negative 12x minus 9, all divided by 3x plus 4 quantity squared. So I have two linear terms that I can combine. 12x minus 12x is just going to be 0, so those are just going to 0 out. And then I also have plus 16 minus 9, and 16 minus 9 is going to be 7. So the derivative of f would be 7 over 3x plus 4 squared, and we can see that's answer choice C. Number 2, if y is x squared times tangent of x, determine the derivative of y. I'm going to put little parentheses around that x. So we need to find the derivative of y. And here we've got a product of two functions. So we're going to use the product rule. So y prime is going to be the derivative of the first, which is 2x, times the second function, plus the first function, x squared, times the derivative of the second. So this is one of the new derivatives that we uncovered today. The derivative of tangent x is secant squared x. So that's our answer. Now, if you cannot memorize that, or if you struggle to memorize that the derivative of tangent is secant squared, you can always derive it by finding the derivative of sine x over cosine x using the quotient rule. So this is going to be the same thing as the derivative of tangent x. And hopefully you at least know what the derivatives of sine and cosine are, so that you can use the quotient rule and figure out what the derivative of tangent is without memorizing it. Now, it's probably just going to be easier to go ahead and memorize it. But if you just have a brain fart or something, you just cannot recall what it is, you can always find it by using that quotient rule. Okay, 2b is very similar here. We've got a product of two functions, both transcendental, by the way. The previous one had an algebraic and a transcendental, and here we've got two transcendentals. So dy dx, which is just another way of saying y prime, is going to equal the derivative of the first, which is e to the x, times the second, which is secant x, Again, I kind of like putting some parentheses around that x. Not totally necessary, but I should have put those in there. Anyway, plus the first function, which is e to the x, times the derivative of the second. Now, this is another one of those new trig or transcendental, well, it's actually both trig and transcendental derivatives. Secant x, the derivative of secant is secant times tangent. So we have secant x times tangent x. And don't worry about simplifying that. That's just going to be our answer right there. Number 3, if the tangent line to this function at 4, 3 passes through the point 0, 2, we want to find the value of the function at 4 and the value of the slope at 4. So if this line, if the line is tangent to this function at 4, 3, that means 4, 3 is a point on the graph. So f of 4 is 3. You don't really have to do any calculations there. You just have to understand what the question's saying. Now we've got a line that's also passing through the point 0, 2. So what we need is the slope of that line. So to find the slope between those 2 points, I'm going to have y2 minus y1, or 2 minus 3, over x2 minus x1, 0 minus 4, and I get negative 1 over negative 4, which is 1/4. So this is the slope of that tangent line. This is the slope when x is 4. So there you go. That's both the value of the function and the value of the slope at x equals 4. Number 4, we're given a cubic equation. And it says determine all values of x for which y has a horizontal tangent line. So I've asked this before, and I'm going to keep asking it. When y has a horizontal tangent line, basically that means that y prime equals 0. Okay, the slope of a horizontal line is 0. So first, let's find y prime. We're going to use the power rule all the way down here. 3x squared minus 18x plus 24. And I want to know, when does that equal 0? So I'm going to solve this equation after I set it equal to 0. Now it looks like all 3 of these coefficients are divisible by 3. So just to simplify the factoring a little bit, I'm going to divide both sides of my equation by 3. Now 3x squared divided by 3 is just x squared. 18 divided by 3 is going to be 6, so minus 6x. And 24 divided by 3 is 8. So now we've got a quadratic that's just going to be a little bit easier to solve. The 2 factors here are going to be x, and then each one is going to be, 2 numbers that multiply to give you 8 and add up to negative 6. It's going to be negative 4 and negative 2. So x minus 4 and x minus 2 are my 2 factors. If I set both of those equal to 0 and solve them individually, I'm going to get x equals 4 and x equals 2. And those are your 2 solutions. Number 5, we've got a function v, which is a product of a quadratic and a linear. And we want to find the instantaneous rate of change at t equals 2. Now you could use product rule here, but it's probably going to be easier to go ahead and just distribute this 3t squared. So we got 3t cubed minus 18t squared, and then use the product rule. I'm sorry, not the power rule, rather. You could use product rule here, but I think it's going to be overkill for what we're trying to do. 3 times 3 is 9. 2 times 18, it's going to be 36. Just double check that. Yeah, that all looks good. So now we're trying to find the slope, or the instantaneous rate of change, at 2. So 9 times 2 squared minus 36 times 2. It's going to be 9 times 4, which is 36. And then minus 72 will be negative 36. So the instantaneous rate of change of function v when t is when t is 2 is negative 36. Number 6 says differentiate each of the following. So we're just going to use our derivative properties here. All our derivative rules try to do all of these. So for part A, we've got a product of two functions. So we're going to use the product rule. F prime x is going to be the derivative of the first, which is 15x squared, times the second, plus the first function, 5x cubed, times the derivative of the second. So the derivative of secant x is secant x tangent x. Kind of eaten into the space of part B here, but that's okay. B, we're going to differentiate basically the same exact way here. We got a product of two functions. So g prime is going to be the derivative of the first, which is just e to the x, times the second, plus the first, which is still e to the x, because e to the x is its own derivative, times the derivative of the second. Now the derivative of cotangent x is negative cosecant squared x. Now, I've mentioned this before. I don't really like having these like embedded negatives here. So I'm going to pull that negative sign out purely for aesthetic purposes, just to be able to read this a little easier and write this as minus e to the x times cosecant squared x. Just trying to reduce the number of parentheses that I've got there. Now it's okay to leave it, like this form, but I just I'm not a big fan of having those negative signs kind of in the mix. Okay, letter C. Here we've got a quotient. We've got 4x plus 6 divided by tangent x. So I'm going to see if I can go ahead and just do the quotient rule here without writing down all the different derivatives, because these derivatives shouldn't be too hard to find. Tangent, you're going to have that memorized, and the slope of 4x plus 6 is just 4. So there's not really like a lot to remember here. We just need to know what the quotient rule says. And the quotient rule says if we want to differentiate a quotient, we're going to take the derivative of the top, which is 4, times the bottom function, which is tangent x, minus the top function, which is 4x plus 6. Let me zoom in here a little bit, try to clean this up. Times the derivative of the bottom. Now this requires the derivative of tangent, but hopefully you're starting to remember that that is going to be secant squared x. All over tangent x times itself, so tangent squared x. Okay, that looks pretty good. All right, let's move on to number 7. It says the parabola y equals ax squared plus b has a tangent line with a slope of 12 at the point 3, 1. Find a and b. Okay, so let's first find the derivative of y. We'll call it dy dx. Just to switch it up a little bit. Normally I would write y prime, but don't want to just never use dy dx because I don't want to forget it, in May that means the same thing. Okay, so the derivative here is going to be 2a times x. Yeah, that's really all there is to it. And so I'm going to use this to figure out what a is, because I know the slope is 12 when x is 3. So the slope is 12 when x is 3. So here I've got 12 equals 6a. I can divide both sides by 6 and figure out that a is 2. Now that I know a, I can use that to find b. I know that y equals ax squared plus b. And I know 3, 1 is on the curve. So I can plug that into x and y. 1 equals, and I got a to be 2, right? Remember, don't forget that. 1 equals a is 2 times the x is 3 squared plus b. And really I'm just doing this so that I can figure out what b is. So we've got 3 squared is 9 times 2 is 18 So we'll do 1 minus 18 is negative 17. And yeah, that's it. We don't really have to do anything else with it. So we found that value of A, and we found the value of B. Number 8, determine the derivative. Oh my god. Yeah, this is a crazy long equation here. But I'm looking at it and I don't see anything that stands out as being like too. I know it's a super long equation, but I'm not seeing any instances where we have to use product or quotient rule. So all of these are transcendental. So we really just, I guess, are testing to make sure we know our transcendental derivatives. So we're going to differentiate each one of these separately. So the derivative of 8 sine x is going to be 8 cosine x. The derivative of 5 cosine x is going to be negative 5 sine x. I'm already kind of moving too far over, I think. Let's bring this back a little bit. All right, then the derivative of negative 8 tangent x. Well, the derivative of tangent x is secant squared x. So this should be minus 8 secant squared x. Okay, so I did this one, this one. I'm going to just check these off as I do them so don't make sure not to miss any. Okay, so the derivative of 2 cotangent x would be negative 2 cosecant squared x, and that's because the derivative of cotangent's negative cosecant x, or cosecant squared x. Then we have negative 3 cosecant x. So the derivative of this would be negative 3 times negative cosecant x cotangent x. So how do we want to put this? I think we'll just write it as positive, so plus 3 cosecant x cotangent x. All right, so now we got that one. Derivative of secant, okay, is just going to be secant times tangent. So secant x tangent x. Okay, got that. And then the derivative of e to the x is just itself, so minus 8 e to the x. And then finally 12 times the natural log of x. So plus 12 times x to the negative 1, or you might write that as 12 over x. These two things are the same. This might be the longest answer we've had in this course, if not like for your whole life. I don't know. That's pretty crazy. All right, there's number 8. Little smiley face here, just because I know what you're getting into. All right, number 9. Looks like we got some more limit definition questions. So these are gonna keep throwing these at you. I don't want you to forget what you're actually finding here. And so the function that we're going to find the derivative of is going to be tangent x. So this is going to be equal to the derivative with respect to x of tangent x. And the derivative of tangent x is secant squared x. For part B, the function that we're going to find the derivative of is actually 3 cosecant x. And the derivative of cosecant is negative cosecant times cotangent. So this should be negative 3 cosecant x times cotangent x. Number 10. Looks like we've got a graph. Okay, I might have to zoom out a little bit so we can actually see it all. And so G is defined by the graph, right, graph of G, and then H is defined in terms of G. So part A says determine the derivative of H at X. So we'll have to use quotient rule. The derivative of G is just G prime. So I'm going to say that H prime is equal to the derivative of the top, which would be G prime, times the bottom, so times x squared plus 1, minus the top function, g of x, times the derivative of the bottom, which is 2x, all over x squared plus 1 squared. Let me just do a quick little glance here, make sure everything, I think that's right. Okay, there's really no work to show there. Let me drag this down a little bit. I'm wondering if maybe there was something we could simplify here, but I don't really think there is. Part B, determine the slope of h when x is 1. So we're going to have to plug in 1 everywhere where we see x. So h prime of 1 is going to equal g prime of 1 times 1 squared plus 1 minus g of 1 times 2 times 1 all over, oh, not 2, but 1 squared plus 1 squared. So we're going to have to use the graph to determine g of 1 and g prime 1. Let's see what's happening at 1. So at 1, we've got this point right here. So this coordinate's 1, 3. So g of 1 is 3. Now we got to find the slope of this segment to determine g prime of 1. So I'm up here 1, 2, 3, 4, 5, 6. So I'm going down 6 and 3 more is down 9 over 3 means my slope is negative 3. So yeah, so the slope at 1 is negative 3. So let's see if we can't calculate this. Let me erase some of my little scratch over here. There we go. Okay, so let's see. G prime of 1 we said was negative 3 times 1 plus 1 is 2 minus g of 1, which we said was 3, times 2, so that's times 2, over 1 plus 1 is 2, and 2 squared is 4. So we've got negative 6 minus 6, that's negative 12 divided by 4 is negative 3. Let's get that negative sign to look a little better. Okay, so yeah, h of the value of the derivative of h at 1 is negative 3. Part C wants us to find the derivative of g at 3. Now, at 3, we can see we have a sharp turn here. The slope suddenly changes. It doesn't change gradually. So that means the derivative here just doesn't exist. Full stop. That's all we have to do. Number 11 says determine the derivative of this function. Okay, so looks like we're going to have to use product rule here, with our first function being e to the x and our second function being this whole crazy looking thing. So the derivative of f is going to be f prime g, or the derivative of the first, which is e to the x, times the second, plus the first function, which is e to the x, times the derivative of the second. Okay. So what I want to do here is find the derivative. I'm just going to do a little scratch work out here. Maybe I should change colors so it doesn't get all mixed up here. I need to find the derivative of 3 cotangent x plus 5 secant x. Okay, so I'm just going to kind of do this out to the side here. So derivative of cotangent is negative cosecant squared. So this will be negative 3 cosecant squared x. And then the derivative of secant is secant times tangent. So this should be plus 5 secant x tangent x. And all this stuff is going to go in those brackets. So negative 3 cosecant squared x plus 5 secant x, get rid of that other bracket, I did not leave myself enough space, times tangent of x. And I'm just going to bring out that little derivative symbol a little more so you can see it a little closer, and that's going to be our answer. And on top of that, that's going to close out tonight's homework. So at this point, you've got a lot of derivative rules you're going to be held accountable for knowing. You got to know the definition of the derivative in terms of limits. You got to know your power rule, your product rule, your quotient rule. You have to know that if you're multiplying a function by a constant, that when you take the derivative, the constant just falls down with it. We actually saw that a couple times here, right? This 3, when we differentiated, just kind of fell down. So did the 5. You also have quite a number of transcendental derivatives you got to know. All 6 trig functions, but then also e to the x and natural log x. The good news is, for now, those are the only ones you need to know. We're going to learn more in the next unit, but what we're going to do in the next lesson is look at a physics application of derivatives. So that should be pretty fun because we don't have to learn any new calculus. We're just going to apply it to some more realistic kind of problems. Anyway, thanks for watching, y'all. Please reach out if you have any questions. I hope you all have a great day. I'll see you next time.